We're going to take a look at right triangle trig. You've had the right triangle trig before. We often refer to it as Sohcahtoa, where sine is opposite over hypotenuse, and that's what we have written right here. Cosine, the coa part, is adjacent over hypotenuse. And the toa part is tangent. Tangent is opposite over adjacent. Well, the right triangle trig only works if you have a right triangle. And here we have a right triangle with a right angle given to you in the corner. However, we also need to know in the context of our triangle what is the opposite side, adjacent side, and hypotenuse. Your hypotenuse is always opposite the right angle. Now, in the context of this angle right here, what is the opposite side? What is adjacent? Well, when you're looking at this one here, adjacent means next to. So which side is adjacent to this angle? This one right here. Therefore, by process of elimination, we would refer to this one as your opposite side, which makes sense because it's on the opposite side of the triangle of angle A. Now, suppose we consider this top angle up here. Where would your hypotenuse, adjacent, and opposite be? Well, still opposite the right angle is always your hypotenuse. Your hypotenuse is always the longest side of your right triangle. Now, you should know that adjacent means next to. Here's your angle. This side right here is next to that angle, so that's going to be adjacent, and therefore, this is opposite. You would probably have seen sine, cosine, and tangent before, but you may not have seen cosecant, secant, and cotangent. Cosecant is just the reciprocal of your sine, so that's why we have it written as 1 over sine. Secant is just the reciprocal of cosine, so that's why we have it as 1 over cosine. And then we have cotangent, which is the reciprocal of tangent, so it's 1 over tangent. Now, let's go ahead and use the idea of our Sohcahtoa to help us figure out the sine of our angle. Sine of 30 degrees. Well, here's your 30 degrees. Sine is opposite over hypotenuse. Opposite is x. Hypotenuse is your 2x. And x over 2x reduces down to 1/2. Cosine of 30 degrees. Cosine's adjacent, your x, square root of 3, over your 2x, and the x's drop. And so then we get just a root 3 over 2. We also have tangent of 30. Tangent, according to this, is opposite over hypotenuse. Opposite is x. Adjacent is x over root 3. The x is dropped, leaving you 1 over root 3. Hopefully you realize you can't leave a root in the bottom, so you got to multiply the bottom by a root 3 and a root 3 in the top. You multiply out the bottom. A root 3 times a root 3 is a 3. Multiply out the bottom, you get or top, and you get a root 3. So tangent of 30 degrees is root 3 over 3. Now, just as a refresher, this triangle here is one of your special right triangles from your previous course in geometry. Here's your other special right triangle of a 45, 45, 90 right triangle. So let's go ahead and continue to work with this triangle, but now let's start looking at your 60-degree angle down here. So sine of 60 is opposite x root 3 over your hypotenuse of a 2x, and once again the x's drop. Cosine of 60 is adjacent of x over your hypotenuse of 2x, and the x's drop. Tangent of 60 is your opposite of an x root 3 over your adjacent of x, and then once again the x's drop, and you are left with a root 3. So your 30 and 60 sine, cosine, and tangents all come from this first triangle, depending upon which angle you're referring to. This second one here is what we're going to use for our 45, 45, 90 right triangle. We're going to use it for the sine of 45. I'm going to let this be my 45-degree angle we're going to deal with. You could also deal with this one up here. Would not make a difference. You'll get the same answers either way. You take your sine, which is opposite of x, over your adjacent of an x root 2. You'll realize that the x's drop, leaving you with a 1 over root 2. However, keep in mind you don't want to leave a root in the bottom, so you got to multiply the top by root 2 and the bottom by root 2. And we end up multiplying on the top, and we get a root 2. Multiply on the bottom, we get a 2. 45 for your cosine would be adjacent of x over your hypotenuse of an x root 2. Exact same thing, so it will simplify down to the exact same thing. Tangent of 45 is opposite of x over adjacent of x. X over x is 1. You need to go ahead and memorize the sine, cosine, and tangent for all these three angles. Make sure you know these off the top of your head, because you will be having a unit circle quiz over these. 6 trigonometric functions for angle G. Well, here's angle G. Let's first of all write down, if this is my angle, would 32 be opposite or adjacent? And in this case, since it's next to, it's adjacent. This would be your opposite. We know this is your hypotenuse because it's opposite your right triangle or right angles, and it's always the longest side. So sine of G would be your opposite over your hypotenuse, and that does reduce down. You could divide them both by 8. Cosine of G. Cosine is adjacent of 32 over your hypotenuse of 40. And they also reduce down, dividing them both by 8. Then you have your tangent. Tangent is your opposite of 24 over adjacent of 32. And then they also reduce down, dividing them by 8. We then have the reciprocal functions down here. We don't really need to use our triangle to get these. Cotangent right here is just the reciprocal of tangent. So take your tangent fraction, flip it upside down. Secant is the reciprocal of your cosine. So take your cosine answer, flip it upside down. And then cosecant is the reciprocal of your sine. So take your sine answer, flip it upside down. Let's take a look at the 6 trigonometric functions of angle F. Here's angle F. Based on that, this one right here, opposite your right triangle or right angle, is still your hypotenuse. Opposite of angle F is your opposite side, and then the side next to it is your adjacent side. So let's go ahead and do our sine. Sine of angle F is our opposite of 15 over our hypotenuse of 25, and then that does reduce down. Cosine of F. So we take the cosine, which is your adjacent of 20 over your hypotenuse of 25, and that also does reduce down. Tangent of F. Tangent is your opposite of 15 over your adjacent of 20, and then that does reduce down. Then we have the reciprocal functions. Here this is cotangent, so it's a reciprocal of tangent. So you got to take your tangent answer, flip it upside down. Secant is the reciprocal of your cosine. So take your cosine answer, flip it upside down. You also have your cosecant. That's reciprocal of your sine. So take your sine answer, flip it upside down. Now, let's go ahead and find the exact value for x. And then we'll also round it to the nearest tenth, and that can easily be done with your calculator. Now, as you look here, here's your angle. Then when you look at what you are given, you're given dealing with your opposite side, and you are given your hypotenuse. When you think of your Sohcahtoa, which one of these deals with opposite and your hypotenuse? Well, opposite and hypotenuse are the O and the H here, so it's the S one, which is sine. So we're going to go the sine of our angle of 60 equals our opposite, which is x, over our hypotenuse, which is 12. The sine of 60 is one that you're supposed to have memorized. We looked at it on the previous slides. Sine of 60 is root 3 over 2. So I'm going to replace sine of 60 with a root 3 over 2. Now all I have to do is go ahead and try to solve it for x. So I'm going to just cross multiply, take my 2 times my x, and that's how I get this. And then I'll take my 12 times my root 3, and that's how I get this here. Then I need to go ahead and get rid of the 2 by dividing both sides by 2, and your 12 divided by 2 is a 6 in front of your root. This is your exact answer, and then you could type that into your calculator to get a decimal approximation. Let's go ahead here and find our exact answer. In this case, this is your angle once again, this is your opposite side, this is your adjacent side. So when you think of Sohcahtoa, that is the toa part, and so therefore you're going to be dealing with tangent. So you're going to go tangent of your 60 degrees is equal to your opposite, which is x, over your adjacent, which is 5. Tangent of 60 is one you're supposed to have memorized. Tangent of 60 is right here, which is a square root of 3. So I'll replace our tangent of 60 with a root 3. Keep the right side the same. Now we've got to get x by itself, so you got to undo your dividing by 5, so multiply both sides by 5. Angle of elevation and angle of depression. Angle of elevation, if you're down here in your kayak looking up at the lighthouse, and this happens to be Split Rock Lighthouse on Lake Superior. When you're here looking from the horizontal and looking up, this right here is referred to as your angle of elevation. However, if you are up at the lighthouse and looking down to the kayaker, looking from here, the angle down from the elevation is referred to as your angle of depression. So let's go ahead and take a look at this one here. We have a ski run. You're told the angle of the ski hill. You're told the vertical drop. Estimate the length of the run. You were not given a diagram here, so I would first of all draw myself a right triangle. Everything here is going to be a right triangle. You're told that it drops up and down 1,800 feet, so we have that. We're trying to figure out how long the run is, and that's always the angled slope that you go down on a ski hill. You're told that the angle of elevation, that's your angle from the horizontal going up to the top of the hill, is 15.7. We now need to go ahead and find this side right here, which is your hypotenuse. This is your angle, that's your hypotenuse. This is your opposite side. When you think of Sohcahtoa, what deals with opposite and hypotenuse? That's sine. So we're going to go the sine of our angle equals our opposite over our hypotenuse. Well, it's really a fraction equaling a fraction. So then you can cross multiply, taking your h times your sine of 15.7 and your 1 times your 1800. Then to get h by itself, we're going to go ahead and divide both sides by the sine of 15.7. This is referred to as our calculator-ready form. We type it into our calculator, and we get a decimal approximation of close to 6,652 feet.